If we consider a basic addition problem, like 157 plus 96. When we add these, we line up the numbers vertically, where we match the places. We match the ones place, the tens place, etc. And then we add from right to left. 7 plus 6 is 13. We write down the 3 and we carry the 1. Then we have 1 plus 5 plus 9 is 15. So we write down the 5 and carry the 1. We then have 1 plus 1 is 2. This idea of carrying is also known as regrouping. In this video, I want to look at this algorithm and answer a couple of questions. Like, why is it that we add column by column? Why do we start on the right instead of starting on the left? Why do we regroup? And how does understanding this algorithm develop for children? Let's look at this problem a little more. 157 plus 96. We can draw a picture to help us understand this problem. We'll let a big square represent 100. Vertical lines represent the tens. And little squares represent the ones. So here I have 157. For 96, I would need 9 of the vertical bars and 6 little squares. And then we can combine things. So we can write this symbolically. If I look at it represented by this diagram here, this means we have one 100 block, 5 10 blocks, and 7 1 blocks. And to that, we want to add 9 10 blocks and 6 1 blocks. And we can look at here and count. We can see that all together, we now have 13 1 blocks. Total, we have 14 10 blocks. And we have 1 100 block. But this is not the nice expanded form that we need. And instead, what we're going to do, and what most children would want to do, is regroup things. If I look at these, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I could regroup 10 of these to become 1 bar. So now I can see that I have 3 ones left over. For my tens, I have 9 tens down here. And then we're going to group 1 more. So left over, we have 1, 2, 3, 4, 5 for this one here. And now we have 2 groups of 100. So we have 253, which is exactly the answer we got whenever we used our standard algorithm. And this regrouping of the physical representation is the same as the regrouping process in our algorithm. It's the same thing as carrying the 1 in our addition algorithm. So we can see our addition algorithm with this idea of things like base 10 blocks and combining some to use bigger pieces, combining 10 of the ones to get 1 10 block, combining 10 of the tens to get 1 100 block. And this is, like I said, the idea of carrying in our standard algorithm. This right here is a great way to represent the addition algorithm for children who are just learning about it and learning about this idea of carrying, to use number blocks or picture diagrams like this one here to see the carrying process that we do in our standard algorithm. The questions we wanted to ask. First, why do we add column by column? Well, that's because we're adding the objects that are the same size. I'm adding the 10 blocks together, I'm adding the 1 blocks together, the 100 blocks, etc. Why do we start at the right? Well, that's because this is our smallest piece. We're going to be able to group some of these and give them over to the tens column. So we don't want to add the tens first because we might have an extra one from the ones in our carrying process. Let's look at one more. 127 plus 285. We'll have our 100 block, 2 10 blocks, and 7 1 blocks. For 285, we need 2 100 blocks, 8 10 blocks, and 5 1 blocks. As we regroup, we have 5 and 5 make 10. We have 2 1 blocks left over. For our 10 blocks, we have 8 here. 2 more gives us a total of 10. So if I group those, we can see we have 1 10 block left, the one that we got from all of the ones. And then our 100 blocks, we have 1, 2, 3, and 4 with this one here that we regrouped. So 412. Let's look at decimals, 0.843 plus 5.6. In a previous video, I talked about using the idea of objects or bundled objects to represent decimals as long as the meaning of the one object is interpreted suitably. So I'm going to let my blocks represent 0.001. We then have our lines will represent 0.01. Our larger squares will represent 0.1, and then to represent 1, we'll use a cube. So to do these, we would have 0.843. So we have 8 of the big squares, 4 of the lines, and 3 blocks. With the 5.6, the only thing is we need our scale to be the same since we're in the same addition problem. So we have 5 cubes, and then 6 of the squares. And now we can start regrouping. We can see that we only have 3 of these, the 0.001 blocks. The 0.01 blocks, we have 4. Those will not regroup. And then my squares, I have 1, 2, 3, 4, 5, 6, 7, 8 here. So grouping 2 more would give me the 10 that I need. We have 4 left over. And then my cubes, I have 1, 2, 3, 4, 5, and then 6 for this one that I grouped. So 6.443. Let's try to do this with the standard algorithm. So we have 0.843 plus 5.6. And when we do this, we line up the decimals. And lining up the decimals is ensuring that we're using the same scale in our blocks. So this is the purpose of lining up the decimals. Students often like to place zeros in these blank spots so that everything lines up, and that's perfectly fine. It's not required, but it doesn't hurt anything. 3 plus 0 is 3. 4 plus 0 is 4. 8 plus 6 is 14, so we write down the 4 and carry the 1. That indicates that we're taking 10 of these and regrouping it to be the larger block, and there are 4 left over. And then 1 plus 0 plus 5 is 6. And the decimals once again line up, so 6.443.